Hi everyone, welcome to my video. So today I'm going to tell you about diode and full wave rectifier. Now let's get started. So my name is Adelora and you can call me Anna. My matrix number is 01 DEE20143 and I'm from DEE2C. Now, I'm going to introduce you about diode. Okay, so basically, a diode is just a small device that let current flow in one direction only. Like, if the current goes the correct way, it will pass through. But if it goes the wrong way, the diode just block it. So, it's kind like controlling which way the current is allowed to go. You can imagine like a one-way valve, like water that can only flow one direction. Totally same concept. The diode makes sure the current doesn't flow backward, because if it does, it can actually damage the other component in the circuit. That's why diodes are really important in things like power supplies and rectifier. Then, a diode is made from two types of materials, P-type and N-type. The P-type has more positive charges, which we call holes, and N-type has more electrons, which are negative. When we combine them, it forms something called a PN junction, and that's the part that actually controls the current flow. And lastly, the P side is called the anode and the N side is called the cathode. So, for the diode to work, you need to connect the anode to positive and the cathode to negative. If you switch it around, nothing will happen. The current just won't flow. Next, I'm going to explain you the function of a diode. Okay, so for the function of a diode, the main one is rectification. This means it converts AC, which is alternating current, into DC, which is direct current. AC current keep changing direction, but DC flow in one direction only. So, the diode help to cut off the negative part of the AC signal and make it more like DC. Next, diodes are widely used in power supplies, especially in things like chargers and adapters. For example, when you charge your phone, the power from the socket is AC, but your phone need DC. So, the diode inside help convert the current into a usable form. Besides that, diodes also protect circuits by preventing reverse current flow. If current suddenly flow in the wrong direction, it can damage sensitive components. So, the diode acts like a safety barrier to block that reverse current. Lastly, diode can also be used for voltage regulation and light emission. For voltage regulation, certain types of diode help maintain a stable voltage in a circuit. And for light emission, we have LED, which produce light when current flow through them. That's why LED are commonly used in inductors and lightning. Okay, so this circuit is actually an example of what I have just explained earlier about how diodes work and how they control current flow. First, we have the AC supply, which is 240 volt, and it goes straight through the transformer T1. The transformer step down the voltage to a lower level, so it's safer and suitable for the circuit. Then, the AC voltage goes into its bridge rectifier, which is made up of 4 diodes. So, based on what I have told you before, diode only allow current to flow in one direction, right? This is exactly how the rectifier works. During the positive half cycle of the AC input, two of the diodes will turn on, meaning they are forward biased and they allow current to flow through the load resistor RL. At the same time, the other two diodes will block the current. Then, when the AC enters the negative half cycle, the direction of the input change. But here's the interesting part. The other pair of diodes will now turn on and the previous one will turn off. Even though the input direction changed, the current through the load resistor still flows in the same direction. So basically, the diode are redirecting the current so it doesn't reverse. Because of this, both half of the AC signal are used and the output becomes a pulsating DC voltage. So in short, the circuit clearly show how diode act like a one-way gate, make sure current only flow in one direction, which is now AC is converted into DC. So, in conclusion, rectifier play a crucial role in modern electrical and electronic systems because they convert alternating current AC into direct current DC, which is required by most electronic devices. Without rectifier, the AC power supply from main sources cannot be used effectively by components such as microcontroller, circuits and battery. In real-world application, rectifiers are widely used in power supply for devices like laptop, mobile phone and television, ensuring stable and usable DC voltage. They are also essential in battery charging system, where AC input must be converted to DC to store energy safely. In industrial application, rectifiers are used in producers such as electroplating, welding, and motor drive, where controlled DC power is necessary. Overall, rectifiers are fundamental in bringing the gap between power generation and practical usage, making them indispensable in both everyday electronic and large-scale electrical systems. That's all for today. Thank you for watching. Bye.